What is going on, ladies and gents? I hope that you and your families had a wonderful Memorial Day weekend. It was really nice weather. Hint, I'm doing this on Memorial Day. So I know it's very nice weather. So I really hope that you took some time for yourself to relax with everything that's kind of going on in the world. We're getting close to the end. Like I said, these next few lessons are going to be mainly surrounding Algebra 2 or things that could help you with Algebra 2. Cat's chilling up there for today. We're just going to jump into it. So today we're going to talk about what is the area of a sector. Now, unless you know what a sector is, or you pause the video and look it up, you're like, what the heck is a sector? Well, that's what we're going to talk about. But before we can actually get into that, let's talk about circles. Okay, so last week we talked about solving equations and stuff like that, and now we're going back to circles, and we're actually going to kind of use a lot of those facts and things that we talked about, So I just want to let you know that this lesson is going to look a little bit different. We actually created this lesson literally right before this whole situation happened. I love this lesson so much. So I decided that I'm going to just do it anyway. I'm going to modify it, because clearly you can't talk back to me, raising your hands and participate. So I'm going to try to do the best I can, because I think this is a really interesting lesson. So let's just talk about it. I want you to brainstorm. What comes to mind when you think of circles? Take a second. Think to yourself. Yeah, you can talk about inscribed, central angles, all that kind of stuff. Think back to middle school. What things did you learn in middle school or even elementary school about circles? Yeah, so hopefully some of you said radius and diameter. Hopefully some of you said the center or circumference. But I encourage you, what other things, like more basic than these four things, did you learn? Other than circumference, which is essentially the perimeter of a circle. What other things or formulas did you learn? Yeah, hopefully you said the area of a circle. And the area of a circle is the following. The area of a circle is pi r squared, where r is the radius, okay? And pi is a constant, 3.14159, so on and so forth. It's irrational, goes on forever, no pattern. Awesome number that shows up literally everywhere in mathematics. So that's number one. Number two, what I want you to make sure that you remember is that, I'm going to write it up here, that what's the relationship between the radius and the diameter of a circle? So if we had a circle, right, the radius, which we already know, is a line that goes from the center of the circle to a point on the circle, and the diameter is essentially a chord that goes through the center. So we know that the diameter is 2 times the radius. So the diameter is 2 times the radius. So if I take the radius of a circle and multiply it by 2, you'll get the diameter. If I have a diameter of a circle and I divide it by 2, or cutting it in half, you get the radius. Now, these are things that hopefully that you came up with about what you think when it comes to circles. It's like dogs happening outside of what's going on. So what I think of when I think of circles is actually pizza. I think of pizza. I love pizza. Pizza is one of my favorite things to eat. And it's funny, there's something that happened kind of right before this whole pandemic happened, which is so funny. And it actually relates to what we're going to be learning today. Okay, so let's talk about it. I'm going to read this, and I actually want you to try to do it on your own, and then I'm going to go over it. So, it wasn't yesterday, but it actually was yesterday when I made this lesson a long time ago. But basically, when we were in B-Tech, myself and Miss James ordered a plain pizza from Domino's for lunch. Pizza Hut, nah. So before we sat down, we got our pizza, Mr. Billy walks by our room and asks if he could eat with us. And we're like, all right, sure. But But Mr. Ability, of course, he was like, you know what, but I want to add pineapples to half of the pizza. So, long story short, James and I are eating lunch. Mr. Ability walks by and it's like, hey, can I eat some pizza with you? But I want to put pineapples on half of the pizza because he likes pineapples on his pizza. So given that the diameter of the pizza is 14 inches, what is the area of half of the pizza so that Mr. Ability knows how much pineapples to bring? And I want you to round it to the nearest whole inch. So the first thing that you got to think to yourself is, well, it's asking me for the area of a pizza. Pizza is a circle. What's the area of a circle? I'll give it to you. It's pi r squared. So what I encourage you to do is determine the area of half of the pizza to see how much pineapples Mr. Ability should be bringing. Alright, so we have area equals pi r squared. The only variables in this equation is r, which is the radius, right? That's the only thing we're going to substitute in for because we're finding the area and pi is a number. It's 3.14159, so on and so forth, right? So I'm going to rewrite it as area equals pi times the radius, which we'll have to figure out, to the second power. What's the radius? If you said 14, I'm sorry, but that's not correct. 14 represents the diameter of the pizza. You can see the line going straight across. But if you remember from before, the relationship between a radius and a diameter is that the diameter is double the radius. So if the diameter is 14, to get the radius, you just got to divide by 2. 14 divided by 2 is 7, so I know that the radius is 7. So I'm going to substitute that in. Alright, now we can just use our calculator. Now you can either use your calculator if you have one of these at home, or you can just use your phone. I will tell you that if you take your calculator, right? Take your calculator and you turn it to the side. I don't know if you can see this, but if you turn your calculator to the side, assuming that you have an Apple phone, I'm sure it's very similar with Androids or whatever. In the middle on the bottom is a pi symbol. Use pi. Don't put 3.14. It should work closely, but you could develop rounding errors because 3.14 is not pi. It's like rounded, right? So you want to use pi, which is the irrational number. Okay. Anyways, so I'm going to put all this in on my calculator, exactly how it looks like, and let's see what we get. Okay, so that I got that the area is 153.938, so on and so forth. But it wants me to round to the nearest inch. So I'm going to write this out, 153.938 dot dot dot. But it wants me to round to the nearest inch. So here's my nearest inch, so I'm going to look to the number to the right. That number is either 5 or greater than 5, so this rounds up to 154. If you wrote 154, you're still wrong because it says round to the nearest whole inch. So we need to write 154 inches squared. Okay? But here's the thing. When we found the area of this pizza, this is the whole pizza. So we're not done yet. So we want half of the pizza. How do you get half of 154? Divide by 2. So 154 divided by 2 is 77 inches squared. So the true area of Mr. Ability's slice, which is half of the pizza, is 77 inches squared. Okay? Now, super important that I want to point out. On your calculator, if you do 154 divided by 2, That's cutting it in half, right? That's 77 inches. Another way you could do that is 154 times 1/2. If you put that on your calculator, you also get 77. Multiplying by 1/2 is the same thing as dividing by 2. Quickly, I can show you, and this relates to what we did last week, right? So if I have 1 divided by 2 times 154, remember, you multiply straight across for fractions. So 154 times 1 is 154. 2 times 1 is 2. And now we're back to 154 divided by 2, which is 77. It's the same thing. Okay, so last question. Just out of curiosity, what was the angle measurement of Mr. Bility's slice? So something that maybe you might have thought of when I asked you what comes to mind when you think of circles is hopefully you also thought of that circles, the angle measurement of a circle, it creates 360 degrees. So if I'm cutting a circle in half, right? Check this out. It's a straight line. What's the measure of a straight line? 180 degrees. So his slice, angle measurement, is 180 degrees. And I want you to see something. In a circle, circles are 360 degrees. So another way we could write this is that he's going to eat 180 degrees out of the 360 degrees of the circle. So check this out. 180 out of 360. Now, I'm not going to do it now, but if you want, pause the video, put 180 divided by 360 on your calculator and see what you get. It's kind of interesting and it's going to be used in just a little bit. Let's move on. Alright, so let's continue. So now Miss James is like, you know what? Well, I want to add mushrooms to my pizza. So what if Miss James added mushrooms to 1/4 of the pizza? How could we determine the area of her slice? Round to the nearest whole inch. So again, pause the video, try it on your own. It's very, 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 very similar, but not congruent to what we just did, but it's a little bit different. So the first thing that you want to think about is, well, she wants to add it to 1/4 of a pizza. 1/4 is 1/4. Right? So, what we could do is we could find the area of a pizza. Remember, this is the same pizza. Remember, this is the radius, right? We just cut the picture. You can see that I literally took this part of the pizza, and that's here. So this is 7 inches, right? So the area of the pizza, area is pi r squared. Now we want to find the area of Miss James's slice before we divide it by 2 in the end, right? Or multiplied by 1/2. But now we have 1/4 of a pizza. So what do you think we're going to do in the end? Yeah, since we only want 1/4 of the pizza, we're just going to either divide by 4 to get 1/4 of the pizza, or multiply by 1/4. It's the same thing. So let's do it. We got area. We got the area is equal to pi times the radius, which is the same thing. So 7 squared. Alright, so when we get this, remember, pi times 7 squared, I could write 154, but that means I'm rounding it, and I'm not ready to round yet. So when I evaluate this, I get 153.938, so on and so forth. Not going to round yet, because I'm going to round in the end. And remember, I need 1/4 of this, so I'm going to divide by 4, or multiply by 1/4. It's the same thing. And you get 38.48, so rounding that to the nearest whole number is just 38 inches squared. Alright, so you may be asking, well, when are we going to talk about sectors? We've been doing it since the beginning of this lesson, actually. A sector is a pi slice. It's a part of a circle. So mathematically, the definition would be, it's the area between 2 radii and the connecting arc of the circle. So if you look at this picture on the right, here's a radius, and here's the center. So this is 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 the center. So Here's another radius. And those two radii, the plural of radius, is kind of like outlines the wedge of a circle. Okay? And that is what we call a sector. All right? So you can see with pizza, it's like a pizza slice, or if you're talking about pie, they're pie slices. So when we talk about area of a sector, we're trying to find the area of these like pie slices, which we have been doing, right? If I wanted half of the pizza, you find the area of the circle, divide by 2. If I want the quarter of a pizza, or quarter of a circle, you would find the area, divide by 4, multiply by a fourth. But the question really is, well, what if I want to find something that wasn't a half, or wasn't a quarter of the circle? What if I wanted to find something that is 0.38946 of a circle? You know what I mean? Like what if it was a crazier number than something simple like a half and a quarter, right? So let's see if there's a pattern. Okay, so this is what we got for both of our questions. With Mr. Bility's slice, right, we found the area of the circle multiplied by a half. Or we could say divide by 2, but you'll see why I'm using fractions in a second. For Miss James's area of her slice, she wanted a quarter. So we found the area of the circle divided by 4, or we multiplied by a fourth. It's the same thing. So this is going to kind of help us derive, remember, create or come up with, how to find the area of any sector. So I want you to ask yourself, what things are the same? So if we're trying to find the area of a sector, okay, so area, A stands for area. I'm putting a subscript of S so that we know we're talking about the area of a sector. What is the same? Well, this pi times 7 to the second power, right? Isn't that the pi r squared part of the area of a circle? So pi, the radius squared, that's the same in both questions. But what was different were these fractions. So my most important question for you is, what do the fractions represent? So hopefully you said that the fractions represent the part of the circle. Okay? So remember, a half was half of the circle, a quarter was a quarter of the circle. Now before, when we talked about Bility's slice, I asked you, what was the angle measurement of his pizza slice? So if we go back, half of his pizza slice, right, was 180 degrees. And we said that's the same thing as 180 out of 360, right? So let's check this out. So his pizza slice was 180 degrees, right? And isn't that out of 360 degrees? Well, yeah, right? The whole circle is 360, and he wanted 180 of the 360. Well, what's 180 divided by 360? So if you do that on your calculator, it's 0.5. But what's 0.5? 1/2. Let's do the same thing for Miss James's slice. So let's go back. Miss James's slice was a quarter of the pizza. If you check this out, I made it a little bit more obvious. A quarter of a pizza is 90 degrees, right? 360 divided by 4 is 90. So she wanted 90 degrees out of 360. And just to show you where this comes from, 90 divided by 360 is 0.25. Do it on your calculator. But 0.25 is the same thing as 1/4. So these things are the same. So check it out. What is the same about both of these fractions? 360 degrees. Okay, 360 degrees are the same. But what's different? The angles. How do you represent angles mathematically? For example, if our angle is a variable, what variable do we use to represent angles? Think back to trigonometry. Theta. That is the formula to find the area of any sector. The area of a sector is the angle of the sector, right? So Mr. Bility's case would be 180. Miss James would be 90, divide that by 360, and then multiply it by pi times the radius squared. And that's how you get the area of a sector. So, being very obvious, the password for this week is pizza. The password for this week is pizza. Here, I'm going to write it here. Okay? Again, the password for this week is pizza. Can't be more obvious than that. All right. So let's do some examples. All right. So how could we determine the area of Mr. DeSeuss's pepperoni slice? So I wanted to get pepperoni. So my pizza slice happens to be 30 degrees. Okay? What could we do if I want to find the area of this slice of pizza? Yeah, let's use the formula. So let's just fill in what we have. Anytime you have a formula, right, and you're going to see this a lot in Algebra 2. Anytime you have a formula, right, there are things that you can substitute into that formula, and the things that you can substitute in that formula will be given in the problem. So what's given in this problem is the radius and the angle measurement. So we got this, we got this. So the area of a sector is, my angle measurement is 30, so 30 degrees out of 360 times pi times the radius, which is 7 squared. So I'm going to use my calculator and let's just see what we get. So I get 12.828. Now I'm going to run with the conditions that we had in the other problem. Let's round to the nearest whole inch. So 12.828 rounds to 13 inches squared. Okay. So why don't we do some examples? These will be very closely related to what you're going to see in the practice problems. So let's just do it. Okay, example. The area of a sector of a circle with the radius of 8 inches and formed by a central angle that measures 60 degrees. So I know we're going to talk about sectors, so I'm going to be using this formula. Anytime that you're using a formula, you want to find the things inside the question to see what you can substitute into that formula. So it gives us the radius, and it tells us that this central angle is 60 degrees. Now you might be like, I don't know what that is. But if you remember back when we first started circles, the central angle is the angle starting from the center of the circle. So it looks something like this. It's saying that this angle is 60 degrees. That's the angle of our pizza slice, or our sector. So all we got to do now is substitute into our formula and use our calculator and solve. So I'm going to put this on my calculator. They will always tell you what to round to. I forgot to put it here, so let's just round to the nearest whole inch, and let's see what we got. So I got 33.5103, rounding to the nearest whole inch. Actually, let me write it out for you. So I got 33.510 ... rounding it to the nearest whole inch. Here's 5, so we must round up. So the area of the sector is 34 inches squared. Let's do another example. Okay, a circle with a diameter of 10 centimeters and the central angle of 30 degrees is drawn below. What is the area to the nearest tenth of a square centimeter of the sector formed by a 30-degree angle? Okay, we're finding area of a sector. We got to use the formula. All right, so we have our formula here. Let's see if we can outline any specific information. So they want us to find the area of the sector formed by the 30-degree angle. So that's this person over here. So we have 30 degrees, so we have our theta. But they don't give us the radius. What do they give us instead? Yeah, the diameter. They tell us that the whole diameter, or the diameter, is 10 centimeters. So, remember from the beginning of the lesson, how does the diameter relate to the radius? The diameter is double the radius, right? So if we want the radius is half the diameter. So if the diameter is 10, the radius is 5. So let's just substitute in, simplify, and round to the nearest tenth. So I get that the area of this sector is equal to 6.5449, so on and so forth, centimeters squared. We want to round to the nearest tenth. So this place is the 10th place, so we need to look to the next place. 4 is below 5, so we're going to keep it as 6.5. So the area of this sector is 6.5 centimeters squared. Okay, let's do another example. So we're gonna up the difficulty, but not by much. So I'm gonna put this here because I already know, obviously, that we're gonna talk about area of a sector. Let's read the question. In the diagram below of circle O, GO is 8, and the measure of GOJ is 60 degrees. What is the area in terms of pi of the shaded region? Okay, so this is a multi-layered question. I want you to try this on your own before watching me go over it. The best way to learn is to make mistakes and then see how to fix those mistakes. So try it on your own first. All right, let's do it together. Now, there's a little bit more crazier things going on here, but let's just talk about a couple of things. Number one, it's asking us to find the area of basically everything but this region. So we're going to have to think about that for a second. And the second thing it says in terms of pi. This is actually something that you did a lot in middle school. When something says in terms of pi, or really in terms of a variable, but you're going to see it say in terms of pi, that means we're not going to evaluate pi. I'll explain that explicitly when we go through this question, but all that means is you're not touching pi. You're going to leave pi there. You're going to leave it. Don't touch it. All right? What we could do is we have 60 and we have the radius. So what we could do is we could find the area of the yellow slice. But that doesn't help us. We want everything but the yellow slice. So can you come up with a plan that we could figure, or that we could do, to get the area of everything else? Yeah, so what we could do is we could find the area of the entire circle. And then we can subtract the area of the yellow slice, and we'll be left with this like Pac-Man kind of thing. Do you know what Pac-Man is? Do you all know what Pac-Man is? Alright, it'd be really funny if you guys don't know what Pac-Man is. But anyways, so that's what we're going to do. Find the area of the whole circle, and then we're going to subtract the area of our pizza slice. So, the area of a circle in general, so the area of O is pi times the radius, which is 8 squared. Now remember, we're going to keep it in terms of pi, which means we don't touch pi. I'm going to show you what that is. So if we want to find the area of O in terms of pi, we're going to keep pi, and 8 squared is 64. So the area of O is 64 pi. You see how I didn't evaluate pi? The reason why we do that is when you multiply by pi, because it's irrational, you're going to always, shouldn't say always, but you're going to get an irrational number, which is going to make us have fractions and all these different like rounding errors and stuff like that. So by keeping pi there, it kind of helps us simplify the problem a little bit more. Back to the problem. All right, so we got that the area of the entire circle is 64 pi. Now we're going to find the area. Actually, let me make this a little bit more obvious. We found the area of the entire circle. Now we're going to find the area of this pizza slice. Okay? And the way to do that is we're going to use the formula. All we need to do is substitute in what we know. We know the angle of that slice is 60 degrees, and the radius is 8. Okay? So, we want to keep it in terms of pi. So I'm literally going to multiply everything but pi. So I'm going to do this step by step, because I want you to see where this is coming from. So we got area equals 60 divided by 360. I'm going to leave pi here. 8 squared is 64. Now what I'm going to do is I'm going to multiply 60 over 360 times 64, and this is what I'm going to get. So we get 32 over 3 pi. Okay, we get a fraction. And it's okay that we get a fraction. That's not a big deal. It's really not a big deal. So let's see what happens next. So this is the area of our sector. Boom. So what we're going to do next is we said it's the area. Let me not use purple. We said it's the area of the whole region, right? That's the area of the circle, minus the area of our sector will give us that Pac-Man slice, that other wedge. It's kind of like a wedge of cheese, I guess. So the area of our whole circle is 64 pi, minus the area of our sector, which is 32 over 3 pi, and that is, actually, I think I want to show you rigorously how this works. I'm going to scroll down, and I want you to see something. Let me take it to the next level, right? So you could put this on your calculator, but you're not going to leave it in terms of pi. Do you see how they both share pi? What I was going to tell you was you can just do 64 minus 32 over 3 and then just leave pi there. But the question is, well, why are you allowed to do that? And I'm not a fan of just telling you how to do things without telling you why you can do them. I don't believe in that. Because math is not magic. There are reasons why we can do things. So for example, since both of these terms, remember the word terms, since both of those terms share pi, you can factor out pi. And you're left with this. Pi times 64 minus 32 over 3. Now I can do 64 minus 32 divided by 3, and I get 160 over 3. So this becomes 160 over 3. And remember, I have pi on the outside, so I can just multiply that by pi. This is our final answer. You could simplify this more. Remember, pi is also just a number, so you can just multiply that back in. Remember how to multiply fractions. So this becomes 160 pi, right, times pi, over 3. And this is our final answer. Okay, I know it sounds like I'm making this more complicated, and it kind of is more complicated because a lot of you don't know these algebraic rules, but I hope at least some of you kind of see the appreciation of, I'm not just going to tell you, just subtract and that's why it works. The reason why it works is you can factor out pi, you can subtract the constants, and then you can multiply pi back in, and that's how you get your final answer. All right, let's do the last example. I'm doing a lot of examples here because there are different ways that this question can be asked. It says, in the diagram below, circle O, the area of the shaded sector of AOC is 12 pi inches squared, and the length of OA is 6 inches. Determine and state the measure of angle AOC. So we know we're going to talk about area of a sector, but this one's a little bit weird. This one actually tells you what the area of the sector is, right? So in this question, it gives us the area of the sector, and they also tell us the length of OA, which is the radius. They tell us that the radius is 6 inches, but now they want us to determine what the angle is. Okay? They love to do this. You're going to see this a lot in Algebra 2, where you're going to learn formulas, you're going to learn different things like this, but it's not always going to be substitute everything on the right-hand side, simplify. Now we actually have to solve an equation. Okay? So it tells us that the area of a sector is 12 pi. So the area of the sector is 12 pi. Okay, I'm just going to rewrite my formula. We don't know the angle. We're looking for the angle. So theta over 360 times the radius. We know the radius is 6, so 6 squared. Okay? And it wants us to determine the measure of that angle. So we're trying to find theta. We've done a question similar to this, I think in the last video. Oh, and I made a mistake. I left out pi. Silly me. Whoop. Pi. So it should be theta over 360 times pi times the radius squared. Okay. We're looking for theta. Try this on your own. See if you can figure it out. And we'll come back. All right. So let's try to do this step by step. Okay. So 6 squared is 36. So I'm going to actually replace this with 36. Now, there are two things that I could do. Actually, there's a lot of things I can do, right? We can use Don't Call Me Impossible. We could use Don't Call Me Impossible. My laptop is dying. We could use Don't Call Me Impossible. So D stands for distribute. Do I got to distribute anything? Nah. Can we combine like terms? Yes and no. I could multiply 36 times pi and get some really crazy number, but I'm going to show you something really cool that we can do. Do we want to move the variable to one side? It's already on one side. It's on the right-hand side. So the only thing that we can do are inverse operations. So there's two things that, there's not two things. There's actually a lot of things you can do, but I'm going to do it step by step. I'm going to divide both sides by 36. Boom. So that gets rid of that 36, but whatever you do to one side, you got to do to the other. So I'm going to divide by this, which is 36. I'm going to write it down here. So on my calculator, if you do 12 divided by 36, that's the same thing as 1/3. So I am left with 1/3 times pi equals theta over 360 times pi. I'm going to scroll down. Okay. Remember, our goal is to get theta by itself. The next thing I can do is, well, I can move pi to the other side. So I'm going to divide both sides by pi. Now remember, pi is a number. It's a constant. It's not necessarily a variable. Actually, I shouldn't say it's not necessarily. It is not a variable. Okay? But the inverse of multiplying is dividing, so these will divide out. But check it out over here. What's pi divided by pi? 1. So these also go away, and you're left with, let's do it in red, we're left with 1/3 equals theta over 360. We're so close. All we need to do is get theta by itself. So what's the inverse of dividing by 360? Multiplying by 360. So we're going to multiply both sides by 360. And on my calculator, I'm going to do 1/3 times 360, and I get 120. So theta equals 120 degrees. Now let me just scroll up for a second. It says determine and state the measure of AOC, the measure of angle AOC. So I'm going to write that the measure of angle AOC is 120 degrees. And that's it. So to quickly summarize, if you have a circle and we want to find the area of a sector, which is just like a pizza slice of a circle, the formula for the area of a sector is the angle of the sector divided by 360 degrees times the area of the circle, which is pi r squared. Okay. I would say that this lesson ranged from easy to difficult because, again, the purpose of math is to really add on to the things that you already know. You already knew how to find area. In fact, I'm sure a lot of you knew how to find area of like half of a circle or a quarter of a circle. So we generalize that. How do you do that? Well, we notice that if you just multiply by the angle of the sector over 360, that gives you the thing that you need to multiply to the area of the circle to get part of the circle. Okay? So hopefully this was helpful. Again, if you found that any part of this was confusing or you need more help, office hours. We're there every single day. We're very lenient with office hours, so if you can't make that 10 to 11 block that technically office hours are, reach out to us. Ms. James, Ms. Fu, myself, we're all available. We're all here to help. We're so close to the end. We will make it there, okay? Enjoy the rest of your day. Enjoy your week. And I'll talk to you later. See you later, everyone.